Welcome to test corrections for chapters 1 through 3. If presented with a 5-number summary, you can build a box plot with those 5 numbers, 92 being the minimum, 110 is Q1, etc. So they want to know what percent of women weigh between 92 and 160. Well, 92 is the minimum, and 160 is Q3. So that should be 75%. Number 2, females have more variability. The evidence is that the standard deviation of the females is more than for the males. Once again, the standard deviation is bigger for the females than it is for the males. For skewed distributions, one should use the median and the IQR for center and spread. The mean would be deceiving. The mean is affected by outliers, which is not an accurate representation of the center. Okay, number 4, we see that GRE examinations are normally distributed. So I can use the formula Z equals X minus mu over sigma. So I want to find the Z score, which is negative 0.427. Next, we want to find the proportion of scores that fall below 500, which is about 33%. Number 5, we want to be in the top 10%. So once again, I want to use this formula. But since I want to be in the top 10%, that means I want to calculate the 90th percentile. Inverse norm 0.9 will give you the Z-score for the 90th percentile, which will allow you to solve for X. So you should get about 675. For number 6, we're looking for the median of the distribution, which should be across from the 50th percentile. I'm looking at a cumulative relative frequency graph. So if we go across from 50% and then go down from there, that's about 6. If you were to draw a box plot, which shape would it look like? The key here is to look at how flat the ogive is from about 12 to 27. There's quite a bit of variability here, which only represents about 10%. So 10% of your values range from about 12 to 28. That makes the distribution skewed right. Number 8, you had a comment about the direction, form, and strength of this scatter plot. So we say that the direction is positive, the form is linear, and the strength is moderate. If we were to add 4.5, 8 to this scatter plot, that would be about here. Before that purple dot was placed there, I would expect the line of best fit to be something like this. But I believe 4.5, 8 would make this line more horizontal, which would decrease the value of R. The correlation would get weaker. The correlation was probably about 0.5 in the beginning. This dot should make the R value a little weaker. We have 200 children. We expect 50% of those 200 children to be between the first and third quartile. 50% of 200 is 100. So the answer is C. For this one, since the residual plot shows a pattern, you can see there's some kind of a curved pattern to it, then a linear model is just not appropriate. If I was to multiply each person's guess by 5, the new mean will be 5 times the old mean. If I subtract each person's guess by 10, the new standard deviation will actually be the old standard deviation. Subtracting does not change the spread of your data. This normal probability plot shows a curved pattern in it. So that tells me that the data is not approximately normal. The data is not normal because the plot has a pattern.